Welcome to the session on expressing infinite solutions for trig on solving literal equations. Okay, now before we start in with examples of solving specific literal equations, I just kind of want to give you a bird's eye picture of how I think of this. Suppose you're here at point A and you basically take some actions and you move here, 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 and let's say you end up here at point B. Well, if you had a bird's eye view, you could just retrace your steps by taking a direct line from B to A if you wanted to get, let's say, back to A, which you consider your home. But if you don't see that bird's eye view, then another way to get home is basically to reverse everything and undo everything in reverse order. So you could go up and then to the left and then up and then to the left again and back here. So in essence what you're doing is you are undoing your actions in reverse order. That's how you'd get back. Now, in math, what is undoing? Well, undoing, you have to think of what undoes what in math. Well, addition and subtraction undo each other. Multiplication and division undo each other. Powers and roots undo each other. And exponents and logarithms undo each other. So keep this in mind as we're working out problems. And let's go ahead and take a look at our first example. Example 1. Suppose I have TR minus L equals P. Now the first time around, let's say we're going to solve for R. The first time around, I'm going to go ahead and write everything out. What you want to think of is what actions occurred or happened to R. So actions on R. Well, first, we multiplied by T. And you might ask, how do I know that? Well, if I were to put a value into R, the first thing I'd do is have to multiply by T, and then I would have to subtract L. So the second action is subtracted L. Now remember, we want to undo this in reverse order. So we want to go in reverse order, which means the first thing we're going to undo is the subtraction. So to undo, we're going to, in reverse order, then first we're going to add L, and then second we're going to divide by T because we had multiplied by T. Now, in truth, I can think these things, but I really, when I'm working these out, here's what I really do. I think in my head, here's what I'm after is R. That's my target. And I really don't care about anything on the other side of the equal sign. So this equal sign is like a little dividing line. And anything that's already on the other side of that equal sign, I don't even pay attention to. But on the same side of the equal sign where T is, I ask myself, what's the thing furthest from the T? And that would be the L. And then I ask myself, well, what's it doing? It's being subtracted. So how do I undo it? Add. So I add L to both sides to preserve the equation. And so then I just am left with TR equal to P plus L. Now I ask myself, okay, I'm still looking for r, my target. What's the thing furthest away? Well, it's just the t. What's t doing? It's multiplying. So what do I have to do? Divide. What I do to one side, I have to do to the other to preserve that equality. And remember, the t's cancel out. So you're left with r equals p plus l over t. Let's take a look at our second example. So in this one, we'll step it up a bit. Q divided by n cubed plus j equals L. And suppose you're asked to solve for Q. Alright, so again, I never pay attention to anything on the other side of the equal sign. So I have Q over n cubed plus j equals L. I think of my little dividing line. And then on the same side as Q, what's the thing furthest away? It's the j. What's j doing? It's being added. So what do I have to do? Subtract it. But what I do to one side, I have to do the other, so I subtract it from both sides. Now, therefore the minus j undoes the positive j, and I'm left with q divided by n cubed equals L minus j. Now again, here's my dividing line. I'm looking for my target q. What's the thing furthest away? Is it the n or the cube? Well, if I were to put a value into q, I would first divide it by n and then I would cube it. So what I'm going to have to undo is the cube. That's the last thing done. So I'm going to take the cube root, because remember, powers and roots undo each other. So if I have a power, I got to undo that power with a root. And what I do to one side, I have got to do to the other. So there we go. The cube root will undo the cube. I'll be left with q over n equals cube root of L minus j. And now, again, here's my little dividing line. The thing furthest from the q is the n. What's n doing? It's dividing. So I want to multiply both sides by n. So I'll have q equals, and I'll probably write the n in front of the cube root. It looks a little nicer. N times the cube root of L minus j. And there's my answer. For our third example, we'll look at square root of p plus k minus t, all of that divided by r, equal to s. And suppose we have to solve for p. Now again, remember what I think of is, there's my dividing line at the equal sign. I don't care about anything beyond the equal sign. All I care about is whatever's on the same side as the variable I'm solving. So there's my p, there's my target. Now, what's the thing furthest away? Well, what did I do to p? First thing I did is add k, then I took a square root, then I subtracted t, and then I divided by r. So it looks like the last thing I did was divide by r. So the first thing I'm going to have to undo is the division by r. How do we undo division? Multiplication. So we're going to multiply both sides by r. There we go. So this r cancels that r. And now we're left with square root of p plus k minus t equals rs. Again, remember, just care about what's on the same side as p. There's my target. What's the thing furthest from the p? It's the t. What's it doing? It subtracted, so I'm going to have to add. And what I do to one side, I always have to do to the other. So now I have square root of p plus k equals rs plus t. And now there's my target. What's the thing furthest from the p? Is it the k or the square root? Well, the first thing I did to p was add k, and then I took a square root. So I'm going to have to undo that square root. What undoes the square root? A square. So I'm going to square both sides, and I'll have the square and the square root undo each other. I'm left with p plus k equals the quantity rs plus t squared. And now finally, I can see that the only thing left to undo is that plus k, so I'm going to subtract k from both sides. And I'll get p equals quantity rs plus t squared, and then minus k. And finally, as our last example, we'll look at mn over t plus L, all of that raised to the 5th power equals j, and solve for m. Now here, you might want to pause this and see if you can do it. And I'll just wait a second, and then we'll start. Alright, it looks like I have my equal sign, so I want my target M. What's the thing furthest away from the M on the same side of the equal sign? It's that 5th power. So I'm going to have to take a 5th root of both sides. Alright, so the 5th root and the 5th power undo each other. You have mn over t plus L equals the 5th root of j. Now, what's the thing furthest from the m on the same side? Looks like the L, since it's being added. I want to subtract it. So I have mn over t equals the 5th root of j. And this minus L is outside of that 5th root, so I'm putting a little, I don't know, like a little cliff there. So there we are. Now, what's the thing furthest from the m on the same side? It's the t. Now, technically, you could undo the t and the n at the same time. You could really, at this point, multiply both sides by t over n. But if you think about it, if I put a value in m, the first thing I would do is multiply by n and then divide by t. So since the last thing I did was divide by t, that's the first thing I'm going to undo. So I'm going to multiply both sides by t. And then these t's cancel out. I'm left with mn equals, and I'll bring the t out in front. It really doesn't matter, but times the 5th root of j minus L. Okay. I'm sorry, the 5th root of just j and then minus L. And now, the last thing we have to undo is the n. Since it's multiplying times m, I'm going to divide the n. So now that cancels these out. And m is equal to t times the 5th root of j, then minus L over n. And some people might write this as t 5th root of j minus TL over n. Just a different form, whichever one you want to use. Alright, well thank you very much. Hello,